Adams State College. Great stories begin here.
Good evening, everyone, and welcome to the first lecture in the beginning of the 5th year of Adams State College lectures, public lectures. So it's kind of a milestone, a landmark. And we're kicking off the 5th year of Adams State College faculty lectures with a repeat offender. Mr. Lyle Carbutt has been a speaker for us before. I think he's only given one evening lecture before. He's given lots of daytime lectures. He always gives great lectures on dinosaurs in that period of time. He finished his bachelor's degree in geology here at Adams State College 2 years ago this spring, and he's now an adjunct professor of earth sciences here. So please join me in welcoming tonight's speaker, Mr. Lyle Carbutt.
All right, as you can see, and I'm sure by the advertisements, I'm talking on sauropods. And the picture I have right in front of me is of Gertie the Dinosaur, made back in 1914. It was a short animated film, and from the little research I was able to do on Gertie, it actually helped inspire Walt Disney, doing some of his animation later on. So these sauropods have been around a long time. The first one discovered in the 1800s, and the behavior that is shown in this little short animated film is actually fairly accurate, even for today. They had Gertie doing all sorts of kind of crazy things back then that dinosaurs weren't supposed to do, but now it actually kind of fits. And we'll talk a little bit about that. Some of the topics we'll be discussing tonight are the history of sauropods, their evolution, and their lifestyle and ecology, how they would have lived in their environment, and some of the newer discoveries that have been made in the past few years. Very fascinating one just in Morrison this past year. So their history, sauropod by definition means lizard foot. And honestly, the only thing that they have in common with the feet of lizards is they have 5 digits. If you actually look at the footprints that sauropods leave behind, their back limbs leave behind these big, deep circular depressions, and their front feet actually look a little bit like horseshoes. They have absolutely, as far as the feet goes, nothing other than the 5 digits that a lizard also has. First sauropod was discovered in 1842, discovered by a man by the name of Sir Richard Owen. Oddly enough, he is also the guy who coined the word dinosaur, which means terrible lizard. There had been some other discoveries prior to this. We had at least 3 other dinosaurs that we knew of, those 3 being Iguanodon, Megarasoros, and Hylaeosaurus, all different kinds of dinosaurs. And there's a good picture of Mr. Richard Owen. And actually, when he coined the term dinosaur, it's like one of the last words that's mentioned in that paper. The first sauropod he discovered was named Cetiosaurus, which means whale reptile. The vertebrae reminded him of whale vertebrae. They were nice and big around and looked pretty heavy. And so he thought this was an animal that would have hung out in an aquatic environment. And at the time, it was the largest dinosaur that had been discovered. Its length is about 45 feet. And by sauropod standards, that's not very big. But considering it was larger than the Megalosaurus, the Iguanodon, and the Hylaeosaurus, it was, at the time, that was saying something. And here's a picture of the Cetiosaurus kind of taking a wading trip, and this is another fun little piece of history that we'll get into as well. So one of the first things that they had to figure out was, how did these guys stand up? Did they stand with their feet underneath them? Were they sprawled? What was it? How did they do that? So now, because early on dinosaurs were thought to be these big giant lizards, they must have had a similar posture. And this is the posture that lizards have. It's out in the side and it's sprawled. Well, there's a problem with sauropods. If you want to continue to have this sprawling stance. Now, up there is a skeleton of Diplodocus. And this was funded by Andrew Carnegie. And they mounted it just like this back in the late 1800s, early 1900s. And they put the feet directly underneath. And some guys in Europe, one in particular, said, no, what are you doing? This is a lizard. It should look like this. It's got to have more of a sprawling stance. And he went ahead and made his argument for that. And he drew a nice little picture of this sauropod, what it should look like, according to the science at the time. And I don't know about you, but he looks a little goofy and little like he's had too much to eat. But that was a good sprawling stance. I mean, they drag their bellies. Lizards tend to do that. Well, we had a problem. In order for that to happen, this guy would have had a ready-made ditch for him to crawl in, because sauropods have these massive guts, and they wouldn't have been able to move very much at all. And this was a banter back and forth between European scientists and American scientists, and Carnegie wasn't about to change the mounting of the skeleton, and in fact had several copies made so that the Europeans could also mount them in that same manner. And this went on for quite some time. But we finally had the debate solved in the 1930s. We found some dinosaur tracks that belonged to sauropods. They looked for big old ditches and for belly dragging and also for tail dragging. They didn't find any. There weren't any. So that problem was solved, but of course we also have a brand new set of problems with each one of these guys. So here are the tracks. These are the rear feet here and the front feet here. And they kind of they weren't moving particularly fast. This piece over here is actually the thumb claw that these guys had on their feet as well. Fairly large, but considering their size, they didn't really need to use it for much. Some of the other controversies that we had is that we have them living in the water all this time, and one of the problems that we had with that is, well, they would have run into the water to escape from predators. Well, there's a couple of things wrong with that. They're huge, and the biggest predator is maybe a quarter of their size. Maybe a quarter of their size. There wasn't really any need for them to run away. The other thing that we have is, well, they have their nostrils are placed higher up on their skull, meaning, well, they probably could have gone in the water and used that as, like crocodiles do, up from the water. The problem we run into with that is, in order for them to get totally submerged, they had to go pretty deep, because these animals, on average, are 80 feet long and in the neighborhood of at least 25 tons. In order for them to get that deep, they'd have to bury themselves pretty deep, and the water pressure, in a sense, would just crush their lungs. Now, there's some new ideas that we have with that they didn't really need to do that. They didn't necessarily were afraid of the water. They could actually swim. But we'll discover a little bit about that here in a bit. As far as their evolution is concerned, their ancestors were bipedal. They walked on two legs. And some of the early ones were called prosauropods, meaning before the sauropods. They're thought to be their closest ancestor. And these prosauropods had nice long necks. They had the long tail, the beginnings of that body plan. They had a small head. These guys were both bipedal and quadrupedal. We're not sure of, oh yeah, well, this one is the one that's basically, this is the one that is not quite a sauropod, not quite getting more advanced on the prosauropod. They're still not sure if they've found that, quote unquote missing link. Well, we do have some prosauropods that are bipedal and some that are absolutely quadrupedal. Now, the other thing that's kind of interesting is both of these guys, sauropods and prosauropods, are alive at the same time in the late Triassic, about 205 million years ago. We find both of them. Maybe there needs to be some more examination made on the skeletons. Now, the prosauropods do show up at earlier in the Triassic, before we have our first sauropods. So maybe they'd already branched off and become modified enough that they were totally quadrupedal. This is one of the first ancestors that we have. It's called Argentinosaurus. And as you can see, he's got nice long arms so that he could be both bipedal, but he could also get down on all four legs. He was about 20 feet long, good sized. And the skull is actually fairly long and deep for sauropods, and this is, again, a prosauropod, so the teeth are a little different in these guys. And of course, their size isn't very big. This is another one. This is probably the most common prosauropod when we think of them. This is called a Platyosaurus. And as you can see, nice, good long arms. You'll note that this guy has a nice big thumb claw, and most of these prosauropods did have these gigantic thumb claws. They're still not entirely sure what they were for. They could have been used for defense. Some of the meat eaters were almost this big. Platyosaurus isn't terribly big. He's only about 26 feet. But we had theropods back in those times that were at least 20 feet long. And of course, there were some rather large crocodile-like animals that were bigger, as big and a little bit more robust than some of these other guys. So one of the things that these guys need to survive, you'll notice they don't have anything real specialized for defense. So one of the things you need to do is get big, because that's a great defense. You don't see many wolves going out and attacking larger prey unless there's a whole lot of them. So one of the other things that was curious about these guys, we have these sauropods, and our original ideas was, well, we have them in the Jurassic, and then they're not around after the Jurassic. So it was thought that they'd gone extinct by the end of the Jurassic. But we now know that they survived until the end of the Cretaceous. In fact, these animals are one of the longest survived types of dinosaur around. They go from the Triassic all the way to the very end of the Cretaceous, which is much more than any other kind of dinosaur can really, throughout the fossil record. It's probably the longest lived species or type of dinosaur around. And they're found on every continent except Antarctica. They went everywhere. Africa, Europe, North and South America, and Asia as well. And they tended to do a little bit better on the southern continents for whatever reasons. They tended to survive a lot longer. Here in North America, we have once we get into the Cretaceous, we start having them dwindling off, at least as far as the fossil record will tell us now. And their body plan is pretty much the same. They have the long neck, long tail, nice stout body. There are some variations. And that's where the diversity comes in. We'll see some pretty interesting takes on some of these designs here in the body plan. So here are the 4 different kinds of skulls. The one up top is from a Chinese sauropod, and you can see the teeth are not much more than pencils. Then we have one here called Camarasaurus, which had more spoon-shaped type teeth. And then we have this guy called Brachiosaurus, and it's kind of a little bit in between here. And then we have the Diplodocids, and they have really just peg-like teeth, and they're mostly right up front. And these guys, they all would have fed on good plant material. You can see the nasal cavity here, kind of way up top. So you can understand why there'd be some confusion and why scientists might think, well, they could use that for when they were underwater. This is one of the earliest sauropods that we know of, and once I tell you its name, I bet you can guess where it's from. It's called Camelotia. So that's a nice big clue. European sauropod is about 29.5 feet long. It's making that transition. Again, they're not sure if this is the one because of the time frame, because we still have some dinosaurs that were sauropods a little bit more advanced and had a little bit more robust body plan than that. Then we have another dinosaur below it called Barapasaurus, again, fairly early sauropod, and it's about 60 feet long. And then this one is from Thailand. Its name is Isanosaurus, and it's in a pose that has caused some hand-waving arguments among science. It's positioned back up on its rear feet, and there are still some questions as to whether or not they could do this. But looking at some of where their center of gravity is, it would be right about here. And using that tail as a nice counterbalance, it could still support itself. They might not do so much hand waving on this one, but when we get to some of the larger ones, they might have a problem with it. The Isanosaurus was about, 55 feet long, and this is from the Triassic. So we have a nice, good sauropod. Still, not sure where the ancestor came from or what sort of transitional forms we might have had. Then we have this one from China, and we start to get some of these nice little modifications. As you can see, his tail has a nice little club on it. This guy is called Shunosaurus. And he's fairly small. He's only about 28 feet long. But possible it used that tail for some sort of defense because it was a smaller sauropod. And then in China, this is during the Middle Jurassic, we also have one of the more common modifications. We start to get this elongated neck. And the Chinese sauropods are famous for their incredibly long necks. This dinosaur is called Omiosaurus, and it's about 49 feet long. Most of that's neck. And, start elongating your neck so you can start exploiting a new resource that hasn't been exploited before, the very tops of the trees. This next one is Euhalops, and this is the skull that you guys saw that was up in that top right corner. Another long-necked sauropod from China, but none so long as, and this is another one that would have had not quite the long neck. It had a bit more stocky build. This is called Daltuosaurus. It's about 50 feet long. But by far the sauropod with the longest neck is this guy here called Mamenchisaurus. It's 85 feet long, and over 40 feet of that is neck. Now the problem is they're not sure if it could really raise its head very high because of all that weight. In fact, most of these guys that had these really long necks had their neck bending this way. Really good flexibility this way, but not as much this way. They've done some biomechanical studies. And just for your interest, these two guys in the foreground, this is the ancestor of Tyrannosaurus rex, and there's the ancestor of Triceratops. And yeah, they were fighting even back then.
Do you have any idea, Lyle, how tall that is at the back? How high is its back off the ground?
I say it's at least 15 feet, maybe higher. And this one here, of course, causes its own controversy. This one's from Colorado. This is called Amphicelius. It is by far, if estimates are right, by far the largest of the sauropods and thus far of any dinosaur discovered. Estimates put it in about 160 feet long and a weight of well over 100 tons thus far. Problem that we have with Amphicelius is it was discovered by Edward Cope, and I've been to the site where they found him. The backbone was really well weathered. It was falling apart, and they shipped it back to Cope, and he made a nice drawing of it and extrapolated how large it would have been. This vertebrae, the backbone would have been 8 feet tall. Very large vertebrae. And extrapolating, comparing it to other sauropods, that's where they're getting these very large estimates. Problem is, we don't have the backbone anymore. Nobody's sure what happened to it. We don't know if it was lost in transit. We're just not sure what happened to it. And they've gone through, and a scientist by the name of Ken Carpenter, who used to be with the Denver Museum of Nature and Science and is now working for the College of Eastern Utah, did a lot of study into this and said, well, looking at Cope's work, there's really no reason to doubt what he said. He didn't make this up to trump his rival, Marsh, which they had a really heated rivalry back then, because if he had, Marsh would have called him on it, as he called him on several of his discoveries. In fact, one of the talks that I'm giving in the next couple of weeks, there was a particular sea creature that Cope had put together, but he put the head on the wrong end. And Marsh very publicly pointed that out to him. And but if there was any doubt, Marsh would have pointed that out right away. And Marsh took him at his word. So the problem is, and we've gone back looking for him, but we just haven't found anything. The section that they've looked at, all the bones are really well weathered. We're not sure if we just got to it at the last bit in the 1800s or what happened to him. But by far and away, if the estimates are right, this is the biggest sauropod ever. And then this one is probably the most numerous and the one we know the most about because we found juveniles of it, adults, several different growth stages of it. This is Camarasaurus, also found in Colorado, Utah, Wyoming. Very common dinosaur. It's about 60 feet long, probably about 7 or 8 feet there at the hips, but probably would have been, if its neck went up a little higher, probably would have been about 15 feet tall. But by far one of the most common dinosaurs in the Jurassic at the time. Would have hung out with the likes of Allosaurus and Ceratosaurus, the big meat eaters. And of course, we have to get to Apatosaurus. And for those of you who have watched the Flintstones, this is Dino. This is also the one that everybody calls the Brontosaurus. And of course, it's a great name, the thunder lizard. But unfortunately, when they found it, they also found, they never found the head. And with it being such a large animal and the heads are actually small compared to the rest of the body, they named it anyway, called it Brontosaurus. And there was another one, very similar body plan, but they'd actually found the skull to it. It was called Apatosaurus. Apatosaurus was named a couple of years earlier. And so when they found the skull of another one that they found in the same quarry, they found the skull, they'd actually put a Camarasaurus skull and called it Brontosaurus on this wonderful animal. When they found the skull to this other dinosaur that they dug up in the same quarry, well, the body plan's the same as this guy, but we know what the skull looked like now. Well, it looked just like Apatosaurus. So Brontosaurus, the name dies because science states that whoever names it first, that's the name that stays. Not the most popular, but, and of course, this would be the guy, either him or the Diplodocus down here that is the logo on the Sinclair gas station. So, Apatosaurus, 85 feet long, anywhere between 25 and 30 tons. Often thought to be one of the larger sauropods. Diplodocus, there is a skeleton very much like Diplodocus down in New Mexico that they call Seismosaurus, but recent studies have shown that it is just a very large, very old Diplodocus. So this guy could get anywhere from 90 to well over 100 feet long. Another very large dinosaur. And this one, very fascinating, is the Brachiosaurus. Of course, he's made appearances in Jurassic Park and a Disney movie as well. The fascinating thing about these guys is they're built more like a giraffe. The legs are up higher in the front, giving it this more giraffe-like posture. And the fascinating thing about this is there isn't the modification for this Brachiosaurus is right in here in the toes and the feet. They're very elongated. Compared to the other guys, they sit a little lower. They don't have those kind of modifications, but those modifications actually allow it to be up a little higher than the rest of them. Gives it a different look, and probably would have been able to feed in treetops much easier than the rest of them, so it didn't have to rear up or anything like that. This one is very fascinating, and it's called Megarasoros, found in Niger, Africa. And the fascinating thing about this guy is in its skull. It's got a fairly short neck, so it's kind of bucking the trend here. But in the skull is this battery of teeth found just at the front of the skull. They call them the dinosaur vacuum. This battery of teeth would have been very close to some of these other plant-eating dinosaurs, but again, it's only in the front, so it was possibly related to these other sauropods that had their teeth mostly in the front. The skull is absolutely fascinating and very hollow, held together by just small, thin little bones, and they've done some CT scans on it and found that its head would have been pointed down. They've been able to pinpoint where the inner ear is and where its balance would have been, and it would have actually been towards the ground, which, considering the nice little dentition that it has, it would have been great for feeding on lower plants. And you'll notice that we have the nostrils down here and not up there. That's something I'll get to a little bit later. Then we buck the trend even more. They're supposed to have long necks. This one has the absolute shortest neck of all of these sauropods and has this wonderfully long tail. And it is called Brachiosaurus. And it's a smaller one. It's about 32 feet long. Again, you'll see that even though the nasal cavity is here, we have the nostrils all the way down here. This guy probably wouldn't have been a very low browser of any kind. Again, totally different adaptation, so it probably would have been feeding not on the treetops, but down lower. And then we get into some of these other modifications within the spine. This is Dicraeosaurus. Much larger spine. Maybe it had a fleshy sail on it. Maybe there was some changes between the guys and the girls. So if you wanted to impress a female Dicraeosaurus, you just kind of waved your spine. And again, more spine modification. This is Brachiosaurus. Very high towards the middle. Possibly it made it even look larger to some of the predators around. You know, I could see some eye spots there or whatever if you wanted to, artistic license. And it's about 65 feet long, but early Cretaceous with some of the larger theropods that lived there back then, size doesn't hurt at all. And then here's another fascinating one. This is a Megarasoros. This guy's from South America. Related to the Dicraeosaurus and this Brachiosaurus. And it's right in here, these really high spines that are its wonderful little modification. They're not entirely sure what they're for. There's been argument whether or not it had some flesh in between those spines. But could have been used for display. If it had the flesh in between it, it's thought that it would have restricted the movement of the neck. So there's some argument as to what that was for. And then, as a more extreme example, this is called Augustina, named after Augustine. This guy's also from South America, looking almost a little bit like a stegosaur. But again, for whatever reason, this modification, whether it was for defense or for intimidation, these guys were a little bit, again, more on the small side. It's maybe about 30 feet long. And maybe used it for intimidation or for attracting a mate for whatever reason, but it's just a fascinating sauropod. And then this one here is called, from a family called the Titanosaurs. This one is called Saltosaurus. Again, it's from South America. And as you can see, we have armor on the back, like the Ankylosaurus did. So we had one that had a clubbed tail, and now we have this guy here. And these Titanosaurs were the last surviving of all the sauropods. And one of the largest. In fact, these Titanosaurs in South America, India, and Africa produced, again, some of the largest sauropods that we have today, which we have much more information on than we do for Amphicoelius. One of these is Argentinosaurus. You can see the nice little armor that it has. It's well over 100 feet long, about 100 tons. And this is an entire pack of Giganotosaurus. These guys, for scale, are 40 feet long, 45 feet long, and they are about 12 to 13 feet tall here at the hip. Argentinosaurus, very large. In fact, they found the vertebrae of these guys, and the skeleton's about 30% complete. One of the larger vertebrae is the size of your fridge. I mean, the entire fridge. It's that tall, it's that wide, it's that deep. So, yeah, earth shakers, very large. Now about their lifestyle and where they would have fit in their environment. Of course, they were the largest animals in their respective ecosystem. Nothing got bigger. Some of the smaller ones were 30 feet long. There was one that was actually a little smaller than that, and the largest were 160 feet long. Their weight varies from that of a horse to that of at least 18 elephants. And if each elephant's roughly 6 tons, well, you can do the math. It's well over 100 tons. But not approaching blue whale size, although they're getting there. And these guys lived on land, which is something else. Now, their size is their biggest defense. If you're a big animal, elephants don't get attacked very often. Giraffes, roughly the same thing. The bigger you are, I always tell this to second graders that I go visit every year. I said, okay, if you're going to get in a fight, do you want to fight with me or do you want to fight with one of your fellow students? I'm like, I'm not taking you on. You're too big. And they would have fed primarily on the treetops, although we do have, as you've seen, there are some that are modified to feed a little bit lower. And in some areas, we have more than one type of sauropod found. If these guys are tree browsers, we got a problem. There's only so many trees. So they would have fed on different heights of trees. Each one has a slightly different modified neck. They would have reached one spot or the other. During the Jurassic, these trees would have gotten well over 100 feet tall, so there would have been plenty of vegetation to go around. We have a good example in Colorado. We have at least 3 different kinds of sauropods found, all in the same area. The Camarasaurus, not quite so tall, 7, 8 feet at the hip, feeding on, mid-level here. This is Supersaurus, related to Diplodocus and Apatosaurus. Would have fed on a different height. This guy's, I'd say 15 to 20 feet tall here. Would have fed on something a little bit higher and quite possibly could have reared up and fed even higher. We also have the Brachiosaurus. Now the other thing that we have too is we have more than one of those Diplodocids found in Colorado and in Utah all in the same time period, same time frame. Possible explanation for that is they might have had different migration routes. The other thing that we have to consider is the plants would have had to have grown enormously fast. One of the things that's found in the ecosystem is there's evidence that there was a very high water table, and oxygen content would have slightly increased at that time. So these guys would have had a good chance of growing, and it was also, there were no polar ice caps at the time either. So fairly warm, good environment for plant growth to happen. So the big question is, well, why are they so big? We know it's for defense, but how did they get that way? One of the things that we looked at is, that has been looked at is their ability to take in oxygen. The more oxygen you're able to take in, the more your body can grow and the quicker it can grow. And the more efficiently you take it in, the better off you are. Back in the Triassic, oxygen content wasn't quite what it is today. It was actually lower. Dinosaurs are thought to have had a lung system very much like birds. Birds have a lot of air sacs. And because of this, birds can fly over the Himalayas without huffing and puffing, where we have to have oxygen tanks and everything else. They have no problems with that. They're able to take in air incredibly efficiently. And it was thought that these sauropods would have had this same system. Now they also have a complex system of air sacs, and the other thing is, how would they have been able to hold their necks and their tails in these nice, upright positions, because they would be fairly heavy. Well, they have a nice complex system of air sacs, and there are air spaces in between the vertebrae, which helps lighten the skeleton and actually helps stabilize it as well. In fact, these guys are built like giant suspension bridges, these diplodocids. And we don't find anything like this in nature as far as engineering at all anymore. Mammals don't have that. They're built much more stockily. These guys, their bones are actually fairly hollow, and they had nice space between them. They call it a pneumatized skeleton, so it's filled with air. Actually helps lighten them. And then that goes back to the point of, well, if these guys jumped in the water, they would have sank. Well, if you're filled with air, you float. You're pretty buoyant. So there goes that idea. Thankfully, it's well over 100 years, so I don't think anyone will be terribly upset with me. The other thing is growth rates. Some recent discoveries they've looked at is that these guys grew and how they grew. Now, sauropod babies, we find their eggs. Their eggs are, roughly the size of cantaloupe, good size. When they're born, they're only a foot long. They're cute. They're very cute. They grew incredibly fast. within 5 to 10 years, they reach their adult size. So they would have been packing on some serious pounds in order to get all the muscle mass and everything else. The closest I've found for the equivalent, those of you that have children, if you could feed them the way that sauropods ate, by the time your child went to kindergarten, they'd be over 8 feet tall with this same growth rate. So you need a house with very high ceilings. And luckily, they don't grow that fast. They grow fast enough as it is, but now on their feeding, they don't chew their food. They can't. Their jaws don't move side to side like ours. They just move up and down. They're not designed for chewing whatsoever. So what do? They strip off the vegetation and they swallow it whole. Now, if you notice from that picture of Gertie, that nice circular object that she had in her mouth was a rock. And Seismosaurus, when they found him down in New Mexico, had a lot of these big stones found in the gut area. They're nice and shiny and polished, and they call them gastroliths. And they did some studies to find out, well, did they swallow them to help grind up their food? And at first, it was a great idea. I thought, yeah, they could do that. Well, they started studying birds because birds will swallow stones to help digest their food. And they looked at the stones that these birds had swallowed after they've been in their guts for some time, and they found that they weren't nice and shiny and polished. They were a little different. So they're thinking that, and they don't find these gastroliths in all sauropods that they find. Just a few here and a few there. They're also not the only type of dinosaur that swallows stones like this. So it's thought that maybe they swallowed them on accident, and they just kind of wound up in the gut and stayed there. But they didn't do the churning and everything else. Or it could have been a possibility that those stones kind of washed there, and it's still unclear, but they're fairly sure that they didn't swallow them to help digest their food. Well, if you're eating plants, the other thing that you're going to have is a very enlarged gut. Because if you don't, plant materials are incredibly hard to break down. You need something to help break it down. Lizards, the iguanas that look for seafood off the Galapagos, actually have an enlarged gut, and they also have a partitioned colon where the food will sit there for a while until it's digested. And because it's partitioned and elongated, it actually helps and aids in the digestion. So maybe they had that. Again, we haven't found any sauropod guts. They just don't fossilize all that well. But something to hope for in the future. And again, some of them may have been able to rear up on their hind legs and feed from the treetops. This is still a controversial idea. You could, I guess, start a good argument if you just yelled that out in a paleontology conference. And, then you can leave and have somebody record it for you later. But again, this is plausible because of where their center of gravity is. Now you can imagine something like this Diplodocus or the Supersaurus, because the treetops are so high, even higher than a Brachiosaurus could reach. Brachiosaurus was only about 40 feet tall with its neck extended. And if these treetops are over 100 feet tall, if you can feed up on the very tops of those, you're in pretty good shape. And if your neck also bends this way, if you're feeding and you have your neck straight up, it makes sense for it to bend down to kind of grab all of these different heights from the trees. So it is plausible. However, there will still be arguments about it in the future. Now, their movement, they're viewed as very slow moving. And actually, the footprints tend to suggest, yeah, they were pretty slow moving. Although there has been some recent studies that may call that into question. Most of the footprints that we find for them suggest they move anywhere from 1 to 3 miles an hour. So don't go cruising with a sauropod. If it's not in a hurry, you're not going to get there at all. Now, the new evidence that we have suggests they may have been a little faster than this. Now, why don't the footprints suggest that? Well, because of the different areas and where fossilization happens, that kind of would have been gone. So, oddly enough, if those sauropods were the same weight as an elephant, they could move just as fast, 25 miles an hour. If they were smaller, probably even faster. And looking at the musculature and where the muscle attachments would have been on some of these guys, the larger ones might have been able to run even a little bit faster than this. Now, some of the cool thing that they found up in Morrison, they found some baby sauropod tracks. They only found the back legs, which to the scientists that found them suggest to them that they may have been able to run on their back legs, like some lizards do today. So here's the footprint of this baby sauropod, and there's Abe Lincoln for scale. Not very big, but again, they only find the hind feet, and these guys would have been running on their hind feet, something like this, although possibly with a bit more grace. Again, we have this nice little sprawling stance. These guys would have been running a little bit more like you and me. Their legs are directly underneath them. And they would have needed to, because these guys had predators no matter what size they were. When they're small, roughly a foot long, they have predators to deal with that are 6 foot long, and they would have been a nice little snack for them. Now, nesting, we found a lot of sauropod nests, a lot of them. Some of the biggest ones are down in South America. They found hundreds of them. All of them were destroyed by a flood. They found the embryos of them. So, one of the other things is you're a large animal. One of the things that tends to happen to you as far as evolution is concerned, you don't tend to have many young. It's just too much energy. So things like elephants, their gestation time is very long. They have one baby every so many years. It takes them a while to have that baby. Sauropods kind of circumvent that by laying a lot and a lot of eggs. You find hundreds of them, a little bit more like sea turtles today, trying to, flood the market so that you still have some that are surviving. And of course, it would have been much like what happens to some sea turtles, I would imagine. They start heading towards the beach, and there's a giant buffet for whatever wants to eat them. Possibly would have happened to these guys as well. Again, the sheer numbers would have secured their survival, and if they could in fact run, maybe they got away a little bit quicker. No parental care. Sorry, they didn't sit on their eggs. Would have been very painful. They wouldn't have lasted very long. There are arguments that they would have had sentries posted at some of these nesting sites, but we don't really see any evidence for that. That's something that the Discovery Channel promoted. I don't know how much weight to give to it. But probably no parental care, but again, they don't necessarily need it. And the young were on their own for years. They probably would have formed little groups of their own, and then as they grew, 5 to 10 years old, they would join a herd as they came by. So here's a nice big sauropod nest. Tough to kind of see the real size of the eggs, so there's this picture for you. These are chicken eggs for scale. Again, nice, big and round. They would have had a hard shell, just like chicken eggs, no soft, leathery shell. And out pops a nice little 1-foot sauropod and starts its journey to grow. Now, the other thing that we have, it's a nice, really cool discovery, is we have some pygmy sauropods we found in Europe. And they're from Transylvania. So Transylvania is famous for other things than Dracula. At first, they thought, well, this is just a juvenile sauropod. It's just a baby. Now, they started looking at the bones, did some cross-sections of the bones, and there are growth lines on these bones, kind of like a tree. And there are also interesting things where the bones start to fuse. So, when your little guys are born, their bones are still fairly loose and not fused together. As they grow, they start to fuse. The same thing was found on this guy, that all the bones were fused, so it was an adult. So why was it so small? Well, there's a picture of it, and it doesn't really give you a good idea of how big it is. They're supposed to say that tree is supposed to indicate something. Its name is Megarasoros. It's about 17 feet long. So it's not very big. It's related to those Titanosaurs like Saltosaurus and Argentinosaurus. But there's a little bit better size for you. So yeah, there's Dino right there. Can be ridden. And this is a human that's, you know, roughly 6 feet tall, about the size of a horse. But again, why was it so small? Well, if we look at the map here, this is 94 million years ago. This is Europe. There's Spain and Portugal. There's England and Ireland, and a few places in between. Not a whole lot of land there. It was a series of island arcs and was that way pretty much since the Jurassic. If you get stuck on an island and there's not a lot of food, you can't get very big in order to survive. We've seen the same thing with elephants. There have been some pygmy and dwarf elephants as well. So it's very possible that this happened, and it wasn't just with sauropods. They found smaller versions of some of the other animals as well that would have preyed on them. Some of the other new findings we have, and of course this one has caused its own deal of controversies. Sauropods could whip their tails and make a crack like a bullwhip. It's long enough, it could have withstood the shock, and in fact it might have actually been able to break the sound barrier. There is a problem with that though, because what happens to a bullwhip? The end gets frayed. So take it for what it is. It's possible that they would have used it, probably not to break the sound barrier, but they might have been able to use it to signal to one another. Possible. The other thing that we look at is where are their nostrils positioned? We've seen them up here, we've seen them down here, and it's very high up on that skull. That nasal cavity is very high. They started looking at it, and one of the things that they looked at also was that there's this big opening in the front of the skull. So there were some scientists that said, well, maybe they even had little trunks like elephants. So they proposed that. It actually looks pretty absurd on a sauropod. And owing to the delicate nature of the trunk and how it needs to be manipulated, it actually doesn't add anything to them when they're feeding, and these guys needed a lot of food. So that idea has been kind of tossed to the wayside, and when they started looking at them, it's just the end of the nasal cavity. They needed nice wet sinuses so they could take in good amounts of oxygen. So they actually had these nice big fleshy nostrils where they could keep them moist, keep everything the way it should be. And so you can see a progression of where we've got it. Again, right up here, there's the nasal cavity. And again, there's this nice opening at the front. So yeah, they thought there might have been a little trunk, and it just doesn't make sense to me. So yeah, this is where they'd had them probably up until the last 10 years ago. And here you can see where it's positioned now. And just so you got more than just a side view, here you see it from the front. And again, this would have been one of those that had been found on most of these guys. It was just a recent discovery, and again, they found out all kinds of fun things about these guys. They weren't terribly bright. Their brains were very small. In fact, out of the dinosaurs, they were the least intelligent, I guess is the nicest way to put it. Cows and so forth actually would have looked like rocket scientists to them. But the thing is, they didn't need a whole lot of smarts, and if you have a very big brain, you have to feed it with enough blood. The bigger it is, the more blood it takes, and if you're positioning yourself on your back legs and you're reaching way up, and you have a big brain, you'd pass out before you actually got to eat anything. So it's a trade-off. These guys are just eating machines. They're not going to do any math for you. They're not going to solve any calculus problems for you. They'll eat. And they'll probably step on things as well. But all right. Are there any questions thus far? If you'd like, I can also show you the little short of Gertie the Dinosaur so you can see it.
How long did they live? Do you have any idea?
It's possible that they would have lived a very long time. I would say 50 years or better. Most of the meat-eating dinosaurs, most of their lives were ended within 30 years. They didn't live very long at all. And in fact, 30 years for a guy like Tyrannosaurus rex is actually grandpa's stage. So, I mean, these guys, once they got to that size and once they got to their full size, they're not going to have any enemies, and they could have possibly lived to, some scientists have even estimated well over 100 years. And they probably continued to grow. That's why they found that giant Seismosaurus down there that's well over 100 feet long. That Supersaurus is over 130 feet long. The fun thing about sauropods is if you find one, you've got work to do for years because they are so large. Any other questions? Yes?
Where in Colorado was the huge sauropod that the backbone's name was? Where was that found?
It was just outside of Canyon City in a little place called Garden Park. I was up there just this last summer working on some of the bones up there, and it was some hard work. We were working with jackhammers to get the bones out. The rock there was very much like cement. And in fact, when Cope and Marsh were there in those same areas, they were using dynamite. Not terribly, careful. In fact, you can find the pieces of bones that they didn't dig up everywhere. But yeah, it was right here in Colorado, right outside of Canyon City. If you go to the Museum of Western Colorado in Fruita, you can actually see a replica of that backbone. And you're standing here, and the top of it is here. It's just a nice little cardboard cutout, but you get an idea of just how large the thing was. Other questions? Yes, sir.
You had mentioned that the longer necks were to feed on the higher treetops, but you also mentioned that the sauropods with the really long necks weren't able to lift them up very high. And so I was wondering if you could explain.
Well, they weren't able to lift them up. They've done the mechanical studies said they didn't lift them up this way. They would have actually had more maneuvering this way. If they were to feed on treetops, they would have had to rear up and do it. And if they did that, then the neck being flexible this way would have helped them reach those areas.
So those huge ones were able to get on there.
Their center of gravity is right in the back of their hips, right in the back. So if they did lean up, they would have been able to support themselves. And then they had that nice long tail to give them a counterbalance so they wouldn't, fall. Nice little tripod stance there. Other questions? Yes, sir.
Do you have an idea of the way the continents were laid out on the drift about this era?
It varied. During the Triassic, Pangea, all of them are together. As you separate into the Jurassic, North America and South America get separated towards the end of the Jurassic. In the Jurassic and towards the early Cretaceous, Europe and North America are connected, which would have made a nice little land bridge there. Also, we would have had some migration from Asia at times. The northern continents end up splitting from the southern continents, and then you have Gondwana, which is South America, Africa, Antarctica, and Australia, and the subcontinent of India as well. They're kind of towards the south. They start to break up. South America and Africa start to separate, and we actually find very similar fossils on both sides of South America and Africa. Very similar types of dinosaurs. A meat eater called Carbutt in Africa looks very much like the Giganotosaurus in South America. We also have some of these larger sauropods like Argentinosaurus in South America. We also have very similar ones found in Africa as well. Australia breaks off during the Cretaceous and actually partially connected to Asia in the Cretaceous. And there would have been a small bridge there. And at that time in the early Cretaceous, Australia would have experienced polar winters at the time. And there were actually dinosaurs that survived and stayed there during those polar winters. They had incredibly large eye sockets for the darkness that they would have had for 6 months. There were some that migrated in and out of there, but over time those continents shifted. Until, and then during the late Cretaceous, it's a talk I'll be giving on the 9th at noon. There's a nice seaway that actually cuts North America completely in half, so that you have the eastern United States, you have the breadbasket is underwater, and you have the west on the other side. And evolution actually took different paths on both sides. You have these nice horned ceratopsians in the west. You don't even have that in the east. The Tyrannosaurs from the east coast have long arms and 3 claws. The Tyrannosaurs from the west coast have short arms, 2 claws, and a much more robust body. And that interior seaway is partially responsible for some of that. Other questions? Yes?
So you said that sauropods were not found in Antarctica,
No?
but were there other dinosaurs that were found there, or?
Yes. Yes, there were some ankylosaurs found there. Some prosauropods were found in that area. And then a dinosaur that they've nicknamed Elvis was also found there. His name is Cryolophosaurus, the frozen crested lizard. And if any of the kids have ever seen the show Dinosaur Train, they actually make the Cryolophosaurus sound like Elvis. He had a very, the crest actually kind of went up like this on his head, making him look like he had a cool little hairdo. There are others that are found there, and quite a few seagoing reptiles down there. But the digging's a little rough down in Antarctica. There's a few places to go. Cryolophosaurus was discovered on Mount Kirkpatrick, which I'm not entirely sure of the geography of where that is, but it's a place where you can actually do some digging. Of course, they have some nice big saws to help them there, and I'm not sure. I know they have to go down there during this time of year because it's their summertime. So they have the least amount of getting frostbite. But, other questions? Yes, sir.
How did they reproduce?
Well, that's a whole fun argument in and of itself. I've actually seen people try to practice it, and it's kind of frightening to watch. The other question, too, is they're up so high off the ground, what about their eggs? Well, there's a couple of arguments on how they would have laid their eggs. They could have actually had a shaft that would have come out and actually kind of gone closer to the ground to protect them as they're being dropped. As far as reproducing, it's still unknown. I'm imagining they would have to have something similar to how crocodiles would reproduce. Because their tails aren't, unlike lizards, their tails aren't as flexible as those of lizards, so there's not that kind of position going on. But they would have had to have something where the tail would move and then the reproducing could occur. It's still a bit of a mystery. All we know is, yes, they did, and they were quite successful at it. The method is something that I'm sure scientists have argued about. And I remember watching a TV show where they were actually trying to show the position. It was actually one of those that I've tried to block out of my memory, but it was quite frightening. If it was anything, it'd have to be something close to lizards and crocs, but other than that, just isn't enough information. Yes? Any other questions? Would we care to see Gertie, just for fun?
Yeah.
Where's the volume control?
Inside the cabinet, probably.
Inside.
At the top, you see some knobs.
Not sure.
Up high,
Up high?
some locks, knobs.
Remember, it's 1914, and that's a sea monster. So there he goes, swallowing a stone, or she. Very large appetite, accurate. But the jaw movement, of course, not. She's a dancer. And of course, the director is trying to treat her like a regular animal, so very well behaved sometimes. serpent again. Of course, see, it's she's dragging her tail. Toddler. See, very agile. Of course, that's not right at all, but whoop. Oh, see, rearing. Don't know if it was that accurate, but. Got his revenge. Did have 4 wings. Took me a while to look and figure out that it actually did have 4 wings, but yeah. Drink. And there you have it.
Any other?
Adams State College. Great stories begin here.